So here we have a stationary mass of 1 kilogram. It is pulled along a frictionless 3-meter inclined plane by a constant force of 6 newtons. At the top of the plane, the mass has been displaced by a height of 1 meters. We have to figure out the speed of the mass at the top of the incline. Now, step number 1 is to identify the different types of forces acting on the object, because basis that we will choose either to use the mechanical energy conservation or the work energy principle. So on the object, the first force acting is already shown, which is the applied force 6 Newton. Then we have the gravitational force, which is the weight of the object. So that will be 1g. And then we'll have the normal reaction. And that's it. There is no friction acting on the object since the surface, the inclined plane surface, is frictionless as it is mentioned in the question. Now remember the rule: if conservative forces are present, if only conservative forces are present, then only we apply the mechanical energy conservation. So in this case, if you check the 6 Newton force which is being applied on the object, that is a non-conservative force. So we cannot apply the mechanical energy conservation. Now the only thing left is, of course, the work energy principle. So let us write down the approach. So work done, total work done by all the forces acting on the object should be equal to the change in kinetic energy. Change in kinetic will be final kinetic energy minus initial kinetic energy. Initial kinetic energy is zero. As they have mentioned, the object was stationary at the starting point, and final kinetic energy, let's say, is half into m into v square, and it is the v, which is the speed at the top, which we have to figure out. So now let us try to figure out the total work done. There are three forces acting on the object. We have the normal reaction, we have the applied force, and 1g. So let's write down the total work done will be equal to work done by the normal reaction plus work done by the gravitational force, let's write mg, plus work done by the applied force of 6 newtons. This is the total work done. So let us find individual work done. In case of the normal reaction, work done, let me write down the basic formula for work, which is force into displacement into cos theta. Now in case of normal reaction, you can see normal reaction is always perpendicular to the contact surface. So the object is moving along the incline upwards. Hence, we can say that the angle between the normal reaction and the displacement, this angle is 90 degrees. So in case of normal reaction, the work done will be n multiplied by displacement, which is 3, multiplied by cos 90. Cos 90 is 0, which means work done by the normal reaction is equal to 0. Now remember this as a rule: work done by normal reaction is always zero, since normal reaction is always perpendicular to the contact surface. Now let us try to figure out the work done by the applied force, which is 6 Newton. So work done by the 6 Newton force will be 6 multiplied by 3, which is the displacement, multiplied by cos of 0. Why the angle is 0? Because the 6 Newton is being applied up the incline, even the displacement, even the object is moving in the same direction. So that is why theta will be 0. And this we can write as 18 Newton. So this is the work done by the applied force. Now, to find the work done by the gravitational force, there are two approaches. Method number 1. Let us use the formula for work done by conservative force is equal to negative of change in the potential energy. In this case, it is the gravitational force which we are dealing with. So this should be equal to negative of the change in GPE. So let me write, this will be equal to GPE initial gravitational potential energy minus the final gravitational potential energy. So initially the object was over here on the ground. So the initial gravitational potential energy we can write as 0 minus finally the object is over here. So the GPE will be mgh, where the height is 1 meter. So we will write negative of m into g into 1. Hence, now we can say that the work done by the gravitational force is nothing but negative of mg, which will be equal to mass is 1, and let us take g as 10. So the work done will be negative 10 newtons. Now let us put the values of all these expressions. Work done by normal reaction was 0, plus work done by the gravitational force was negative 10, plus the work done by the 6 Newton force was 18. This was equal to the change in the kinetic energy, which we had figured out was half mv square. So let's write down half. Mass is 1 multiplied by v square. So on the left hand side, we have a 18 minus 10, which we will get as 8. This can be written as v square by 2. So from this, we can write v square is equal to 16. And then if we take square root on both sides, the value of speed will come out as 4. And if we look at the options, it is option B, which is 4 meters per second. And that is the right answer. So here we have a stationary mass of 1 kilogram kept on an inclined plane. The inclined plane does not have any friction as it is mentioned. The object travels up the incline for a distance of 3 meters, and throughout the motion the box is being pulled up by a force of 6 newtons, and the direction of the 6 newton is parallel to the surface of the incline. And when the box reaches the topmost point over here, it is 1 meters above the ground, and we need to figure out the speed of the mass at the top of the incline. So there are various ways of solving this question. Method 1, let us use the basic work energy conversion. And what do I mean by that? Let's analyze the image in detail. So A is the initial point of the box. So A is the initial position of the box where the speed of the box was 0. The box is starting from rest and then it travels up the incline to reach a final position B. So one of the approaches to solve this question is using the work energy conversion. According to that, whenever any sort of a work is done, energy is transferred from one form to another. So in this case, if you analyze, this force of 6 Newton is pulling the box from A to B. So this force of 6 Newton is going to do some work, but that work is going to get translated into other energy forms. And what are those energy forms? The box is going to reach point B with some velocity. So at B, there is a gain in kinetic energy. And also since the object has come above the ground, so potential energy has also increased. So now we can say that work done by this force of 6 newtons is going to increase the GPE and kinetic energy of the object. And the expression becomes the work done by the force will be equal to the change in potential energy plus the change in kinetic energy. Now the applied force is 6 newtons, so we need to figure out the work done by that force. So we use the basic formula F into S into cos theta. Magnitude of force is 6 newtons, displacement is 3 newtons, and the angle between the displacement and the force is 0 degrees. Because you can see in this image, A, B, and the force of 6 newtons are actually parallel to each other, which means the work done by the applied force comes out as 18 newtons. Now, for the change in potential energy as well as change in kinetic energy, we are going to use final minus initial. So for delta PE, we'll write the final potential energy, final gravitational potential energy at B minus the gravitational potential energy at A. That will be delta PE. Similarly, the delta KE will be final kinetic energy minus the initial kinetic energy. Now, GPE at the point B will be mgh, where the height is 1 meters. Point A GPE can be considered as 0 because the height of A is 0. Kinetic energy at B is half mv square. Now that V is what we are supposed to find, and kinetic energy at A is 0 since the object was starting from rest, as it is mentioned in the question. So now if you put all these values in, work done was 18, GPE and kinetic energy expressions we have written down, and then if we try to simplify this, we are going to get 18 is equal to the mass of the box is 1, G is 10, and the height value is 1. So if we simplify all of this, we will get the value of V as 4, which means once the box crosses the point B, it is traveling with a speed of 4 meters per second. Now, coming back to the question, it is option B, which is the right answer. So here we have an object thrown vertically upwards on the surface of the moon. The maximum height that the object can reach is h. When the object reaches h by 3, we have to figure out this ratio of kinetic and GPE. So let us start with drawing a diagram. So imagine we have an object kept on the surface of the moon. It is thrown with some velocity, let's say u. Now it goes up until it reaches a maximum height. Now at that height, we know temporarily the object will become stationary. Its velocity will become 0. That's the maximum height. And that height is given in the question as h. Now the question is, when the object reaches the height of h by 3, what will be the ratio? So in the same diagram, let's say the object reaches this position. Consider this as h by 3. So the diagram, of course, is not drawn to scale, but h by 3 is the height which they require. So at this point, we have to figure out the ratio of kinetic and potential energy. Now, in this question, if you analyze carefully, when the object is going up, it is only under the influence of gravitational force, which is the conservative force, which means we can apply the law of energy conservation, which is the total mechanical energy at one place should be equal to the total mechanical energy at any other place. So for this case, let us label some points. Let's say A is the starting position, B is the maximum height position, and C is the position which is h by 3 from the ground. So according to the law of mechanical energy conservation, first of all, we will equate the energy at A with the energy at B. And total energy we know is the combination of kinetic and potential energy. So the expression will become this Kb plus Pb. Pb stands for the potential energy of the object at B. Now at A, we have assumed the velocity is u. So kinetic energy at A, we will write as half mu square plus potential energy at A, we will consider as 0 since A is on the ground. Kinetic energy at B will be 0 because the ball or the object will become instantaneously stationary at the maximum height. So kinetic energy is 0 plus potential energy at B will be mgh. Now the h height is already given in the question. And let us try to simplify this expression. So we can see m will get cancelled out. We will get u square will come out as 2gh. Now consider this as equation number 1. So how did we arrive at this conclusion? We have equated the energies at A and B. Step 2, we have to equate the energies at A and C. So let's write down to equate the energy of A with C. Again, kinetic energy plus potential energy, both of them we have to consider for A as well as C. So Kc plus Pc. Kinetic energy at A, velocity was u, so it will become half mu square, and the ground potential energy is 0. Now at C, let's say the kinetic energy is Kc and the potential energy will be mgh, but the height for C is h by 3. So we will write potential energy at C will be mg multiplied by h by 3. Now let us try to simplify this expression to get Kc. Let us make Kc as the subject. So on simplification, we will get half mu square minus mg into h by 3. Now previously we had deduced that u square was equal to 2gh. So let's put u square as 2gh in this expression. So we'll get half m u square is 2gh. On the right hand side, we have mgh by 3. So 2 gets cancelled out here. We will get mgh minus mgh by 3. And now if we simplify this, the expression for kinetic energy at the point C will come out as 2 by 3 mgh. Now going back to the question, we were supposed to find the ratio of kinetic energy at h by 3 with the gravitational potential energy at h by 3. So let's write down the Kc we have already found out. Kc is 2 by 3 mgh. We have to figure out the ratio of kinetic energy by potential energy. So kinetic energy we have just calculated is 2 by 3 mgh, and the potential energy at C will be this mgh by 3, which we had written earlier. So in the denominator, we will write mgh divided by 3. And now if we just simplify this, mgh gets cancelled out. The 3 also will get cancelled out, and we will get the ratio as 2. Now, if we go back to the options, 2 exists in option D, and that is the answer to this question. So